Hello. All right. Yeah, thanks so much for attending this session. My name is Truyen Tran. I'm going to be a moderator today for the panel. Thang actually asked me this morning that whether we have a tough question for the panelists. And I thought this is no need because every question is going to be really, really tough. The reason is that expectation for AI today is too high. Anything for the next step would be, life-changing, right? So the theme of this morning is about foundation models. So I'm going to start with a general question about foundation model. So to me, foundation models started around 2018. I think around the birth of BERT, right? I remember Quoc by the time twist that, this is a new ImageNet moment for NLP. And I thought it was kind of right because AlexNet moment was 2012, and we got a quite accurate or object recognition algorithms, but still do a small thing like outputting one label at a time. Whereas language, on the other hand, it's unbounded. So ability to excel the language, I think would bring the AI to the next level. So the question is that I feel at this point, AI, it had reached to the very turning point at the moment in the history. Not less than the AlexNet moment. And I see that for the next 12 months or so, there's been a rapid development in LLMs and a lot of competitions. But then I feel that we're reaching a new kind of computing where machine learning or neural networks become a new kind of computers. We just ask the questions, right? We don't need to program anymore. And we have new experience with the new tools. So in your opinions, how far would this paradigm would go? Whether we could continue like this, or we expect something new happening in the next few years or so. Want to start with first? Jeff? Yes.
Start? Sure. I'm looking forward to hearing the other panelists' opinions as well. I mean, I think the way these models are trained is we're trying to build incredibly general models that can take nearly anything you would ask them to do and to accomplish that. So if you think about the whole set of tasks in the world, how well can you take a model that has been trained in the way these foundation models are trained and then be able to then accomplish a task that it's never seen before, or maybe is somewhat different from something it knows how to do, but maybe a bit different, or something very, very complicated, like maybe something where a human would normally need to break this down into 16 different sub-pieces. Maybe the model can do 14 of them, but it doesn't know how to do the 15th or the 16th. And so if a human was solving that problem, they would then have to do some exploration of how are they going to tackle this particular sub-piece of the problem, and how are they going to put the whole solution together. So I think what we're trying to build are systems that can generalize to new tasks. In the same way that earlier machine learning models, when you train them on a data set, you want them to generalize to new examples. It's just that here the example, instead of just being like a single image or something like that, is now an arbitrary task that we want these models to do. And they clearly can't do all the things we want them to do, but they're getting better. And I think one of the things that's really kind of challenging right now is the kind of multi-step reasoning of these models still needs improvement. Like they sometimes can do 6 or 7 or 8 steps of reasoning. They can't do 1,000 steps of reasoning robustly. And that, I think if we can make them do that, that would make a big improvement. Also to Yitei's points, I think the cost of hardware coming down is making it possible for people to do more experiments, to train as capable models with less compute investment. I think to your point about interacting with people, I think the way in which people interact with these models is a really important focus for how do you make them really effective sort of partners for solving problems that people have.
Yeah.
Yeah, so you touched on reasoning. So I'll talk about superhuman reasoning in my talk. And I think that's actually really the dream that I would like to have. And in fact, I actually want to convince people that we now start to shift from an era of imitation test, where we have been trying to train large language model to imitate human, imitate in how we write poems, to your wife, or a letter to ask your boss to raise your salary, into we still imitate, right? So the question is there a way we can push the boundary so the LLM will go beyond its knowledge boundary and discover new things? And I think we're actually at the verge of that by the fact that actually alpha geometry, alpha proof, discover new solution, more creative thing. And I think it should be that kind of paradigm. I hope that we keep pushing for, so that we can do a lot more exciting things like drug discovery, or like solving unsolved conjectures and things like that.
Quoc, do you have anything to add?
My microphone doesn't work. Okay. So if you think about the current successful paradigm that we have in the LLMs, if you look very closely, it's actually quite simple. So the first step is they do next token prediction. So the next token prediction, even though it's very simple, it turns out it's super powerful. Because if you can predict the next token, you can predict many, many things, right? So that's the first step. But they also realize that next token prediction is limited, because then it cannot give you a very long form response that's very good. So they correct in that with what people call it ILHF, which is, you give preference. You have data on one side is better than the other, and you fine tune the model that way. So the model can give you more better output. But if you think about that, the output that are aligned with our preferences. But if you think about that, that actually is still very simple to solve many problems that we really care about. For example, if you think about building a computer that can solve like what Thang said, to solve like P equal to NP or something like that. Let's say that's to prove or disprove P equal to NP. The theorem that the proof that it's going to generate is going to be very high perplexity, because you never seen that in the training data. That's the first thing. And then, ILHF, you can get millions of examples, but you're never not going to be able to get to a position where it can solve like the way that a mathematician going to solve, because what they are trying to do is to break a problem down into small pieces and then carefully planning how you go solve one piece at a time. So I think if you think about that, seems that the current paradigm misses a lot of things related to another paradigm that AI used to be very good at is search. You need to combine something like the next token prediction with something like search, and how you can correct, how it can plan, do a high-level planning, and then solve one step at a time, and how to verify that each step is correct. So, and that's the reason why if you use ChatGPT or Gemini, you tend to see hallucinations in a lot of steps, because this next token prediction give you errors, a little bit of errors, and then it will compound into a very incorrect response. So I think the paradigm that we see today is actually quite limited, and we will see changes in how people combine it with search and a different objective, where they look at the whole input and they see whether it's correct or not.
So, Diyi, yeah?
Yeah. So I want to mention a few specific aspects. The first is data creation. I think the data is really undervalued in many ways. And when we think about building language models, a lot of times it's about where you find your data. And specifically, a lot of the questions I want to share in my earlier talk is we actually have a lot of users who are not very well represented on internet or on the mainstream corpus we have been looking at. And if we are going to build the technology that can work for people in different countries, think about if you travel there or for the local users, they can actually interact with all the technologies we build. We need data to come in. And this is actually a very challenging process. It's probably okay to crawl the entire internet and do some kind of quality control, but there are rich human natural language interactions in different parts of the world. How to get potential data from this process is actually something very interesting. I think the other thing related to this issue is a lot of data set access control. Who has access to what type of data, and then the privacy, potential leakage of data if not being used very well in the end-stream session. I think all of them are actually important dimensions to think about for the next turning point of AI. The second part related to interaction is also related to data. When we think about the task we are testing models today, it's very static, or it's just like a certain round of interaction. But if you think about how humans do a search, it's probably a sequence of actions. Or how I write an essay is probably revision, draft, criticize, and many, many others. Or how you use, how you do certain type of other task. So it's actually this very rich trajectory of actions involved. And then potentially is this kind of action, or should this kind of action be captured in the pre-training stage, or is that something that we need to build in the product to facilitate, or through this kind of agent perspective? I think that's something very interesting to think about. Ideally, if we could find a way to optimize this kind of end-to-end workflow, then that would create some new possibilities.
Thank you. Yi, from the startup perspective, do you think keep scaling up with a lot of data and compute like this? You're gonna bring...
Well, startup don't have compute to scale up. So.
Because that's the bottleneck for the startup, right?
Yeah, I think like finding interesting ways to do pre-training and post-training is kind of like the angle that most startups have to go for, unless they have like a lot of compute. I still believe in scaling up generally for the field, but I guess it's like there's also there are things like compute optimal, but there's also like cost optimal, right? So like whether like I think the models will get better as we continue to scale up generally, but the only question is that like for startups, does it make sense to scale up when you can get the startups have to optimize for different objective, and unless you're OpenAI, you'll be trying to go for AGI, right? I think most startups are trying to make money. So I think there's a different, there's a intersect between research and business, but like there's I don't really identify as a business person myself, but I just think it's like it's a different perspective, and but I believe in scaling up. It's just that for startups may not have the money and compute to scale up. Yeah.
All right, but you still have the compute, right? Or you have to innovate to do a much faster training with the cheaper solutions.
Yeah, but I think there's also interesting points, like maybe innovation could be like when you're in a compute constrained condition, you may be forced to also like think differently about things and stuff like that. So there could be like some interesting constraints there, but yeah.
Can I make one quick point about that?
Sure.
I mean, I think your point about the hardware improvements is a very good one. Like from generation to generation, you see kind of 3x improvement from last year's chip to this one. But I think there's actually also a lot of improvement from algorithmic improvements and better sort of training recipes and better understanding of the data sets and having higher quality data that is actually almost as big a factor, maybe even more than the raw hardware improvements. So I think those two things kind of multiply together to make this year's model that you're training on newer hardware, maybe 9x better per flop per operation than the ones you're training last year.
Right. So we have touched a very important point, many important points, like reasoning, the need for the new algorithm with maybe symbolic capabilities. or the new way of seeing how AI will interact with human from Diyi's point, and also hardware scaling advances. So touching on the reasoning, I know it's a hard topic right now. There are two camps right now, right? One is that saying that, look, LLM is trying to memorize some sort of reasoning capability from the data into the weight, and what you do in the in context learning is to retrieve those approximate, chain of thoughts or step-by-step reasonings. What do you think about those thinking, like whether the LM really reasons or it's kind of retrieving the pattern that already stored in the weight? Thang, wanna go ahead?
Yeah, well, I think that's a tough question. So, well,
That's what you asked for, right? So,
but maybe I can answer approximate question. So I remember like 2015 when we make a lot of progress in machine translation. At that time, actually, my advisor Chris Manning didn't believe that we can actually really just generate one word at a time, and then we get a real translation, right? And then I think maybe that was like 9 years, 10 years ago. People wouldn't even probably believe that you can just, ask an LLM and it would just generate a perfect poem for you. Well, I still feel like that the LLM really not really do real reasoning, but it do the kind of answer so well that you sort of eventually believe that it actually do good reasoning. I think that's my current feeling.
So I often joke that we need the human to understand LLM. If you tell it to the cat, probably they have no idea, right? So.
But I mean, like I can also comment, like as we use LLM to solve super hard problem at the Olympiad level. So there's certain moment we look at the solution, and it's just amazing. Everything was so coherent. If you was like step back. Maybe a year ago, or maybe only a few months ago, they might make silly mistake in the manipulation, but then it just keep getting better. And then sometimes actually we work with some of the experts, the IMO experts. So sometimes they look at the solution. Actually, there's some novelty there. There's something that they find actually quite different from their expected solution. So I think there's still something going on there. It might not be doing fully reasoning, but I don't know, maybe when we can make the model parameter size like 100x like bigger, like 600 trillion parameters, just like human brain, maybe at that time we cannot distinguish between whether this is like real reasoning or just imitations. I think that's my current thinking.
Yes, go.
Different people have different definition of the word reasoning, right? So it's very hard to say, maybe you have a very high bar for reasoning and we have a different lower bar for reasoning. So, but I think if you ask me, I do think that machines already start to reason. The system that we have for IMO to solve some of the, to win IMO silver medal, you can argue that it's already start to reason. Maybe it's a little bit too slow, but don't underestimate how fast we can make it to, in the next few years, right? Many people say that it's brute force, but I think it's actually really clever. And I mean, if you look very closely in the math data set that, GenAI has made a lot of progress on, actually a lot of questions you can't solve. I can't solve it myself. And the model was able to solve some of these things. And we were so surprised that we were looking into the training data to see evidence of whether they exist in the training data, and we don't find them. So I think there's some genuine reasoning is happening. And so maybe right now, maybe it's at the level, maybe high school, it can solve maybe like up to 10 step reasoning or something like that. Maybe it's not super impressive yet, but I think that's already something that, maybe a decade ago, we would never imagine anything quite like that. So the answer for me is that, yeah, it already started showing some reasoning ability.
Well, Thang just mentioned a very good point that maybe at certain point we cannot tell whether it's machine or humans doing reasoning. So maybe it's a new kind of Turing test instead of just chatting right now, right? So that's a very, very good point. All right, so we do believe that just by scaling up, we would have something keep going like this. We're going to have something amazing happening, right? Even something that we couldn't imagine that now, right? So it raised the point that what's next, because the text is going to be we train on the internet scale text already. So what's going to be next if the text runs out? Jeff, have any idea?
Yeah, I mean, I hear that a lot is where are we going to get interesting data to train these models on? I think there's actually quite a lot of interesting data in the world that can be used for training. So if you think about text, you can, in some cases you could synthesize new and interesting training data from using a model and then train that model on that synthesized data or train a different model. And that can give you additional tokens. I think we really have not tapped video data very much in the world. There's an awful lot of video data. And to Yi's point, there's actually quite a lot of interesting languages and dialects and accents and stuff that are well represented in video data that is not really, very well reflected in textual data on the internet. So I think that's another area that I think is important. I think also being able to generate using search in some domains. And I think one of the things that we see is that search in domains where you can get a clear signal, was your answer or your steps of reasoning correct, are ones that are kind of at the frontier of what we're able to do, and we're actually able to do a pretty good job in those domains. So things like the Math Olympiad, in some cases coding problems are amenable to this as well, because you can generate a lot of solutions. You can see which ones compile, you can then see which ones run and give you reasonable answers according to some set of tests that you might have for that coding problem. Those more formalized domains, I think, are ones where search plus the core capabilities of the model are going to give us the ability to create new data that we can then further use to improve those models. I think it's less clear how we get kind of really nice, rich reward signals for search processes in domains that are not as formalized as, say, coding or math. But if we can do that, that would make the ability to then use search to dramatically improve the model through the search process and generating new data or getting reward signals from it much better.
Yes, you want to?
Yeah, I want to quickly comment on this. Getting data is actually quite challenging, especially for audio or video. They also contain like a bell or private information. So it's like we hear your voice, we know it's you. So there are a lot of this kind of bell information encoded in data. Getting data on the other side also relates to like data protection or giving credit to data producers. So this is also a big challenge. Right now, I think with internet data, there is already a bypass of who is the content creator and are they getting the right credits for the data they produce. I think this issue will become more important if we are going to build multimodal models that require local communities, local users to share their audio, video, all sorts of things. So this is going to be quite a challenging to kind of scale, just to think about. The other thing I think is related to potential risk associated with this process. There are a lot of jailbreaking you can do with text-based models. Think about what if one day you are like jailbreaking the audio models and they start to talk like Jeff for a very different question, right? So in this way, there are a lot of this kind of mimic or in preparation going on. And I think this is when we move forward with scaling, with making the data more scalable, all these kind of issues need to be considered at the same time. Otherwise, we may be at a stage we don't know how to better control what's happening.
Right. So I talked to business, and I think the single most frequent concern is hallucinations in the area like health, banking, or things that require more precise factual answers. So right now, I don't see any like definite solutions to the problems. So do you have any ideas of how things would be solved? Yi, you wanna go with solving hallucination problems?
Yeah, I think hallucinations is like a wide problem for LLMs in general, but I think in many use cases, this can be solved by like some retrieval augmented models, and then as long as like, then there's also like if the model still like sometimes it's because the source documents are bad and stuff like that, and then a lot of this is, there's a lot of like other factors that go into whether the retrieval system is good or not, certain things like that. But I think like for people who want to make like systems reliable for like very specific domains or specific use cases, I think like you could solve like hallucination for like you know, a certain bank in a certain place, like with the specific like data that they use, right? But I think that like if to solve hallucination broadly, generally, and all the time, is very, very hard. But I think like generally, like I think like a RAG style approach, or like or long context plus RAG is probably like the way to reduce it down. Yeah.
Yeah, maybe I can
Yeah,
add
go
on.
ahead.
I think one way to understand hallucinations is that the model is trained to predict the next token. And so that means that it essentially generates sentences that are plausible from a probabilistic standpoint. But not all plausible sentences are true, right? So I think that's where the hallucination problem comes from. And part of it is that when you're training a model on trillions of tokens and essentially mixing all those tokens together in the parameters of a 100 billion parameter model, that is less clearly separated information than things that are available to the model in context. So I agree with Yi that like retrieval-based methods and then using that to focus on that gives the model a very clear view of the things that are in its context window and enables it to, not reduce hallucinations to zero, but to make them much less serious of a problem because it's actually paying attention to information that is directly sort of available to it and not mixed together with all the other trillions of tokens.
Yeah, I can add something. So there's recently some very promising work around detecting hallucination. Before you solve hallucination, you want to detect them first, right? And what they found is that the way you can do this is you take the long response and then you use an LLM to break it into atomic facts. So for a very long response, you can just break it into small little facts, and then for every little fact, you can just query Google and check it. Once you do that, right, you can detect what atomic fact is actually hallucinating. I think just telling the user that this part is hallucinating is already pretty useful. And then on top of that, of course, we found that if you do a retrieval augmented language model, like what Ian Jeff said, it will improve the quality of the model from giving a lot of hallucination to much less. And then if you put this detection inside the reward model, it can also reduce hallucination. So I think there will be progress in this area by combining with a search engine, I think.
I also want to add like, beside detecting hallucination, I think actually if you try to push for like superhuman reasoning, it actually can, the byproduct of that, actually it can solve hallucination. Because you really teach the model to be able to think for very, very long time steps. For example, in alpha geometry, one of the solutions of the hard problems, 100 steps. So, and I think it does connect to, some of the things I think could be the future, like synthetic data generation, where I think you can actually, through solving these very hard problems, through really, where we don't have any data, actually. If you think about Olympiad, right? There's not much data out there. So we really have to think around it. Like, is there a way we can generate massive amount of these kind of very hard, challenging solution? And I do hope that by doing that, we can eventually, cannot tell whether this is hallucination or this is reasoning or not. I think that's my prediction. It's a byproduct of solving reasoning.
No, that's great point. I think, yeah, if it could solve reasoning, and yes, go ahead, Diyi.
I want to argue that sometimes hallucination can be good, especially in creative generation space, and especially in high uncertainty situations like science discovery, where we have no clue of what's going to happen. And in those scenarios, hallucination give you different alternatives. So I view it as one possible positive use of working with scientists or humans to leverage that. The other thing, just like in addition to use retrieval to do verification or citation to provide a citation, is to really think about how can we make models respond with "I don't know" for questions they really don't know. Because if we just ask a really like invalid questions, there's no answer, but they are forced to produce an answer. So in those moments, being like honest and just say "I don't know" seems to be a reasonable solution.
I guess your LLM's ranking will drop if you refuse to answer. Then the LLM's ranking will drop if you refuse too much. Yeah, okay.
That's not what we should work for.
So related to your work, Diyi, so I think that human in the loop as well, right? You don't just ask question and force the system to answer, right? So you have a human in the loop, and then maybe you should enable the human to correct or detect the hallucinations. Is that something you have in mind? Yes.
Are you talking to E?
To you.
Oh,
yeah.
Oh. Yes, I think. So a parallel example I was thinking about when E, I'm D, he's E. So mention about retrieval-based augmentation is doing this kind of external validation. But think about in many political contexts, when we hear all this kind of speech or election debate, it's actually extremely hard to do fact-checking. So I think a human in the loop could be a potential solution. On the other side, there are also a lot of costs associated with that process. And the human, as we know, may not be in the best position to assess the validity of certain statements. So this is just a quick reaction.
Do you want to go? Yeah. You have answer? No. I think we have to maybe turn to the audience. So we'll take the question from the audience, please. Yes, please.
Yeah, thank you very much. I'm Fu from Norex. I have a short question. So we talked a lot about the recent advancements and the futures of generation, like of AI in general, right? But what would be the current limitations or some sort of like bottlenecks that you, as the leaders in the field, right, and working in big companies with all the tremendous resources and funding, you see that it might be hard to break with the current approach? The long elaboration of that is because we've been through a few rounds of AI generation, right, from rule-based, traditional statistical modeling to deep learning. And I still remember at that time the deep learning with CNN and RNN, even though we have worked too back and all, there were certain challenges like handle unknown tokens, which make it not possible to generate precise quantity or like handle named entity and stuff like that. So we know that was the limitation. And because of that, a lot of earlier chatbot approach, it didn't work. So it seems with the new paradigms, we start able to navigate through some of these challenges. So what would be the current sort of limitations in your view that you can see? And the reason I ask is because it might be for on the enterprises or SMEs, right? When they decide, hey, is this the thing to go for? They might need to be aware that there's some sort of limitation because doing commercial stuff and all is not that easy. Yeah, thank you.
I guess it's a long question, so who want to take the challenge?
I mean, maybe I can just generalize it a little bit. I think it's a very good question of like, what are the unsolved problems in this field? I think we've been discussing things like longer-term capable reasoning and multi-step reasoning as one thing that we think would be an important aspect of improving the models. I think Diyi is also focusing on, how do you make the models more capable of general understanding regardless of, people's accents or language spoken. So generalizing these models so that they can deal with, 1,000 languages instead of, pretty well with 10 to 15 is one area. But I think in general, it's good to look at the trajectory of the field as a whole bunch of steps where we've solved problems that we didn't know how to solve and gotten to this point. And now there's a frontier of new unsolved problems, like around reasoning and multi-step planning and so on, that we're currently trying lots of approaches on. And I suspect some of those approaches are going to work and improve these capabilities of these models. If you look back 5 years ago, the models were not nearly as capable as they are today. And if you look forward 5 years, you can imagine they're going to be considerably better than the ones today by solving a lot of these problems, by scaling, having better compute hardware, all these things kind of compound together. It's not as though you can sort of plan research breakthroughs, but if you have enough investigation in the industry or in academia, some ideas will work, some will not work, and they'll be combined together to sort of push things forward.
Yes,
a quick comment is, one thing that I think is unsolved, very important, but not a lot of attention, is actually around the interpretability. So this is something really important. All of us, we are curious about why large language models work, why they can answer this question, why, like so many whys. That's our first reaction. But in fact, it's really hard to dive deep into either the architecture or different stage to figure out what exactly is making the model work. And I think that this is really important, but unfortunately, a lot of the academic work we are doing right now is with like relative small models to figure out like, okay, is it the attention layer, is it the MLP layer that carry many of the undesired signals or desired signals? I think this is something very fundamental and solved.
Yes, please.
Do you think that we can train a human doctor with text and video?
Human doctor?
Yeah.
Okay, that's tough questions. It's not legal yet, okay?
Yeah, I know.
Let's go ahead. Use your imaginations, please.
So, I think if you look at some of the work in this space, there is a lot of improvement in the ability of these models that are focused on medical domains to, make, quite powerful models. Obviously, medicine itself is a highly regulated and complex environment with real privacy concerns and so on. But if you look at the progress, for example, from the MedPalm to MedPalm 2 to MedGemini models that Google has been working on, we're now passing medical board exams, with a very good score as opposed to like just barely passing them with earlier generations. Honestly, I think the right thing is to train models that really augment, human clinicians to make the best decisions and human, patients and people to understand their own health through these models.
Sorry, I like to focus. I like to focus the question in the right aspect, in the sense that human, we used to think that humans are better learner, right? So I try to push, if we say, okay, this is real reasoning, obviously doctor are doing that. If we cannot train the doctor, which means that how can we train a machine to do that, right? So I try to push into forgot about the aspect about legal and practice and other stuff. It is not the focus. The focus is whether the better learner can learn with text or video or either something else that is mixing in the formula.
So I think there's one huge advantage that machine learning based systems have compared to human clinicians. So a human clinician, studies for many years, goes to medical school, they have a residency, a fellowship, and then they practice. And in their career, they might see 20,000, 30,000 patients or something. right? So that is a very real and rich experience of how do they treat those patients, and they, discuss with colleagues around the lunch table interesting cases, so they get some additional experience that way. But a machine learning model can actually learn from many more examples of interesting and rarer conditions. There might be a condition that a machine learning model gets to see 8 times in its training data that a human clinician has never seen, right? And it might then be able to sort of offer the suggestion to a human clinician, there's a 99% chance it's this thing, but there's a 0.5% chance it's this really rare thing, and you should maybe consider what you might want to do in that case. So I think the expertise and skills and advantages and disadvantages are different, but they're going to complement each other in ways that will enable better outcomes for everyone.
So we need the auto-correction of reality, like actually try and fail for the machine, even like so that it can reach there. Like people actually, we cannot learn how to ride bicycle just by like take a video, right? So are you saying that it's the same for like being a doctor? Like need to got a lot of feedback, training that way.
I don't think I said that, but
I can comment one aspect. I think that he was asking about text and video, but I think there's something missing here. I think which is the emotion and the empathy. So I think there's a human aspect that we actually want to bring in this conference. I think like Diyi talk about human-centered LLM. I think we will hear Paul talking about human AI, maybe competition or something like that, like educating humans. So I think these aspects are also quite important, and I think it would require certain deep thought about how do we bring in empathy, emotion into maybe the future doctor.
I think the question from the person who asked, from the question, my interpretation is that is there anything missing in embodiment? Like do we need embodiment or touch sensors or something like that to actually get into the loop to train the foundation models? If I understand that correctly, I think that's what the person is trying to imply. And the answer from my perspective is that I think we are seeing less progress in robotics because I think the lack of a hardware platform to collect data and so on, and simulating sensory data like touch, friction and so on is still very difficult. So if you ask me, can we model a real world physical common sense? I don't think we're at that level yet because of this lack of embodiment data, but maybe Jeff can comment on that more.
Yeah, I was just going to say that medicine is inherently a highly multimodal discipline, right? Like you have, the clinician's eyes experiencing the patient sitting in front of them. You have a bunch of measurements that they're able to obtain from lab work and so on. They have the long-term medical history of the patient. Modern medicine now has genomic information about patients and, genomic information about various kinds of cancers or tumors that the patient has. And then there's a bunch of information that the current medical system doesn't really consider. So I wear like a running watch, and it measures my heart every second. And I don't think, I know my clinician doesn't take into account my multi-year time series of 1-second heart measurements when thinking about what kind of care someone should get. But I think you kind of want all that information that is relevant to health to be part of the combined team of a human clinician plus a machine learning model to provide the best care. And I think there's an opportunity to do that if it's approached in the right way with the right sort of ways of interacting with the human clinician, with the patient, with the right sort of privacy safeguards around the data and the regulatory processes. But I think it's a huge opportunity for the world, and we shouldn't shy away from it just because it's complicated.
So I think this topic is too huge to answer in a few minutes. We have a local doctor, expert here, Dr. Stephen Chung, sitting there. He's actually running a company on the healthcare, AI for healthcare, so you can talk to him. We have time for other questions. Yes, please.
Hi, my name is Tan, and I'm an independent researcher. So there's a research paper by J.P. Morgan published on June 25th, where a renowned economist in MIT, Mr. Darren Acemoglu, he comments that the growth in GenAI recently, it's first of all, it's not performing well for the economy as we expect it to be. The productivity hasn't increased that much. The job creation coming from GenAI also does not create that a lot of jobs. And I quote in his interview with JP Morgan, he also say it's also against human nature. So in that sense, there is obviously a concern versus on the cost versus the benefits, which Yi also mentioned in the beginning. So I want to take that context and move the needle into Vietnam as a focus. So we're here in a GenAI summit where we talked about the GenAI expansion, investment. So in terms of that, I want to throw this question to all the panelists here. So how can we make this whole GenAI thing that benefit the overall societies, create jobs for people that's not even within this GenAI, within this data and machine learning circle, but also jobs for pretty much everyone out there that can benefit from this. So in that context, what would be the right directions for a country like Vietnam, for the people that is not in this room, that outside of this room also can get the benefit from this whole GenAI journey?
It's a big question.
Yeah,
for
maybe he can also say his name and where he's from or something.
I think he already said.
Yeah.
He's an independent researcher, so.
Maybe I make some quick comments and maybe other panelists can comment on it. So for me, I think AI in general and GenAI in particular, I think it's both underhyped and overhyped at the same time. So basically, I think what's going on is that we overhype what it can do in short term, and we underhype what it can do in the long term. And because I think what the root cause of this is that if you the way that we look at the future is we always fit like a linear curve into what progress is going to look like. But if something that is moving more like exponential, anything that we fit the line, is going to look like that you're going to overestimate what it can do in the short term and underestimate what it can do in a very long term. I think what GenAI can do, if you think about it, in 10 years, you're going to go watch all movies that are made by these foundation models. That's incredible. You're going to read most of the text that you're going to read. It's going to be created by these models. Some of the examples that, for example, Jeff presented today from Gemini, completely mind-blowing, right? What it can do, you can just ask it to summarize videos and so on. I think we're going to spend the next 5 years just to use the current model to just build new applications. And that's already, even no progress at all, we can still spend the next 5 years to build really great applications. What we see about ChatGPT and so on is just like the surface of what this model can do. And I think even building new applications already create a lot of opportunities for the world. So that's in terms of underhype and overhype. Now what Vietnam can do, I mean, it would be good to participate in the AI revolution. I mean, you don't want to be left out of it. So I think Vietnam should get into the AI revolution. That's what I think.
Yeah, I mean, maybe I agree with what Quoc said, but I also think, and to add on to it, I think the level of investment is not because of the current capabilities of the model. It's because of the potential of what these models can do if you extrapolate out, a few, 5 years or 10 years. And so, the models can do some things today that are actually quite useful for productivity in various fields. But I think the potential of these models and these sort of generalized AI systems to impact many different areas of human endeavor is what I think people are excited about and will, what researchers in the field are working to advance. And so I think in terms of what people in Vietnam should be thinking about is how can we actually apply AI to problems that matter in Vietnam? How can you, perhaps address problems in the areas of education or healthcare or various other fields that are going to be incredibly useful for society. I mean, I think that's what we all aspire to, is to build things that actually improve the state of the world or the state of Vietnam, and that seems important.
There's one thing that I hope to come from Vietnam, which is a new Alan Turing. So which is why I named our institute a New Turing Institute. So I really hope that there could be someone there, or, new young talents that could do great jobs, do great research in AI, and we have an excellent talent. So by that I mean we want to empower a lot of talent in Vietnam. I think education is important. We want to make a lot of investment in education. Also, thanks to Jeff, Google, and other people, we're looking forward to a lot of opportunities for Vietnam in terms of education.
Yeah, regarding the Vietnam scene, right? There's a very good startup scene in Vietnam at the moment. So, talking to Yi, what is your maybe a bit of exception in your case, but taking from the startup standpoint, what would be good approach taking the current revolutions and make it work for the local business or even going out in context of Vietnam? Do you have any thing to share?
I think there's a lot of progress in the AI models today that as Quoc has mentioned, that if you just try to make use as much as possible, to make as much finding use cases and finding places where there are unsolved problems and then try to fix those with, I think the current models are already very capable to do that, and I think that any country or any organization should try their best to just exploit what is already available, and then I mean, coming back to the broader question that was shared earlier is try to find as many use cases and then fix make impact there, and then trust that the AI researchers will make a more long-term impact, and I'm bullish about AI, so I think that in 5 years and stuff, the capabilities and stuff will be much better. But I think a lot of communities could just a lot of things can be done with the existing models that have not been fully exploited yet. Yeah.
Right. Thank you. We have time for one more questions. One from far back.
Thank you so much for so many great insights. I want to speak from a perspective of a student, perhaps you talk about so many different projects. So I want to ask about how to particularly think about the project that we choose, and how to as students, how do we do our best, possibly during our education, during a PhD, and how can we prepare for a long-term career in the field? Thank you.
Maybe it's Diyi, that's for you.
Yeah,
so I can feel for you, okay? I'm an academic, so I can feel for you, so let Diyi answer it.
Okay. I think this is a great question. First, I think that this is the best time to get involved in research in AI or NLP directions, because there are a lot of great resources online. I think many years ago, there wasn't so many kind of free courses, toolkits, data sets, all sorts of things you can use. Today, I think if you are interested in getting involved, Google Colab provides kind of starting point. There are a lot of data sets, tutorials, courses you can leverage. Second is in terms of what type of questions to focus on. I think it's really important to think very carefully about the project you are going to start in several ways. First, not be influenced by what it's hot or what is hip at this point. I think a lot of people get influenced and then pick something that they probably don't have a lot of passion. So this is the one thing I would recommend. Second is that I think by the end of the day, it's really about your curiosity, which specific direction or things that you personally are more excited about, and then choose that. Of course, sometimes you may have like multiple ideas or multiple directions you are thinking about. At those stage, it's about research taste, kind of like big problems versus small problems. What would a potential impact look like? I think those would be some kind of the criteria to think about. Third, I want to mention is, I think you probably already heard that many people or students actually are very frustrated in today's society because they think that, oh, like if industry labs can also do great research, why not that? I think it's also possible, like instead of pursuing a PhD in academic settings, sometimes getting into very hands-on work at specific companies or startups is also a great way to get experience towards that. And then after that stage, if you are still excited about a PhD, I think that maybe that's the right choice. Having said that, I still think that a PhD is very necessary because it's not only just about a specific problem, it's about the process of how to do research, the process of think, how to do thinking, the process of preparing you to the next few generations or thinking more beyond what we have today.
I think that's great answers. I can add a bit here as an academics. I often advise my students that don't go for the hot topics because by the time you get into it, it's done. And by the time I finish a PhD, the field already move on. So you become a newcomer again and have to relearn again. So it's not a good strategy to just to go for the the shiny ideas and projects. I think we kind of run a bit out of time. I think we better wrap up here.
Can I add one thing to the question? I think one thing that's really important is regardless of how much schooling you decide to do, you want to put yourself in a place in your career where you get to work with people who know things that you don't, and you kind of can collectively do things that are really important in the world. And then what often happens is some of what they know kind of rubs off on you, some of what you know rubs off on them, and then you kind of maybe go your merry way and work on something else, but now you have sort of a broader set of tools and techniques and knowledge and subject areas you know about. And I think it's really important to sort of continue doing that throughout your career rather than thinking, oh, school's done, now I'm going to go do one thing and keep doing that for a long time.
Yeah, I think we better wrap up here. Thanks so much for panel members, and thanks the audience for attending.
Thank you to our panelists, and thank you to our moderator, Mr. Truyen Tran. Please, all of the panelists remain on stage because our organizers would love to bring you some flowers. May I welcome on stage Ms. Wendy Nguyen, co-founder of RHF, and Ms. Scott Friesen, president of Fulbright University, Vietnam. Morning session. Thank you very much for your attention. We will be back at 1:30 p.m. and after this is lunch break. Please go to the 23rd floor for lunch. And thank you so much and goodbye for now. Bữa trưa sẽ được phục vụ ở tại tầng 23. Rất cảm ơn sự quan tâm theo dõi của tất cả quý vị từ đầu chương trình tới bây giờ. Và hy vọng là quý vị sẽ có những trao đổi và những khoảnh thời gian vô cùng là thú vị trong bữa trưa. VIP lunch will be served on the 23rd floor. Bữa trưa của VIP sẽ được diễn ra ở tầng 23. Chúng tôi đã có chỉ dẫn và sẽ có những nhân viên để giúp quý vị lên tầng 23. Xin cảm ơn. Hẹn gặp lại quý vị vào 1 giờ 30 chiều trong buổi chiều nay để phiên buổi chiều được diễn ra. Khách VIP chúng ta sẽ có tiệc trưa ở tại tầng 23 và tất cả quý vị còn lại chúng ta sẽ ăn trưa